Okay, first I will talk about how to solve the problem 3. The problem is there is a machine which can transmit two digital signals, 0 and 1, but it will transmit through a noisy channel, so the received data may be different from the original signal sent out. And the problem suppose if we transmit the 0, it will have 0.7 probability to receive a 0, and so it will have 0.3 probability to receive signal 1. And if we send out the signal 1, we will have 0.2 probability to receive a 0, and so it will be 0.8 probability to receive 1. And what's more, the original case is the machine will send out 0 by 0.6 probability and send out 1 by 0.4. So for the first problem, it is about the probability that data 0 is received. So receive 0 means we can take it into two parts. The first is receive 0 from 0, and the other is receive 0 from 1. So receive 0 from 0 is a joint probability, which means it will first comes from 0 and then it reach this side, which means it will have 0.7 probability. So the probability for this case is 0.6 multiplied by 0.7, and for the other is 0.6 multiplied by 0.4. It means it comes from 1 and it goes to 0, means we will take this root, so it is multiplied by 0.2. so the answer is 0.5. Okay, then the second problem is what's the probability to have an error, which means we transmit a 0 and we receive 1, or we transmit 1 and receive 0. So I can write it into 0 to 1 plus the probability of 1 to 0. And we know it is also a joint probability, which means it comes from 0 which is 0.6 and goes to 1, which is take by this root and multiply by 0.3, and comes from 1, which means 0.4, and goes to 0 means multiply by 0.2. So the answer is 0.26.